Alright, so this unit we're going to get into graphing. And this little cheat sheet in front of you, transformation sheet, can be very helpful. So anything you see here I need you to write down and keep a copy of. Using different colors can be very important to kind of help you understand what transformation you're looking at. Let's kind of go over this as I show you some examples as well. So let's go and look at the first transformation, which is A. A is your vertical stretch. And to figure out if it's going to stretch or compress, you're going to find the absolute value of A. So it's always going to be the value, not the sign. So if A is bigger than 1, it's going to stretch it vertically, meaning up and down. And if it's a fraction that's less than 1 or decimal that's less than 1, but bigger than 0, it's going to be a compression. If it's a negative, we know it's going to be reflected. And the next letter is kind of very similar to B. However, that one's going to be a horizontal reflect. Same rules that apply to A. If it's negative, it's going to be flipped. And we'll kind of see examples of this. The next two, H and K, tell me how much is going to be shifted. Remember, a shift means it's keeping its shape. It's just moving across the coordinate plane. H is going to be horizontal, so left or right. If it says X minus a number, it's going to go to the right. If it says X plus a number, it's going to go to the left. That's because this negative here is already here. So anything added to make it a positive means I'm actually adding a negative number inside of it. Now, K is probably one of the easier ones, because if it's positive, it's going up. If it's negative, it's going down. No tricks to it, anything like that. Understand what horizontal is, vertical. Inside the parentheses with the X affects the value of the X, and outside affects the value of the Y. So you want to make sure you have all of this here written down somewhere to kind of, or typed out, to have it ready to kind of view whenever it's needed from you. It says when we're working with quadratic functions, which are parabolas, it's going to look like this. And when we're working with cubic functions, it's going to look something like this. Now let's kind of look at an example on Desmos. So here I have an example of a parabola. And this is actually my parent function, meaning my original parabola function. And although it doesn't look like it up here, the reason I know is because my A is a 1, which means that's normal. B is a 1, which means that's normal. My H and K are 0, which means my origin is at 0, 0. That's my start. So let's look at what happens when I change things around. Let's go to the H first, which is the shift left and right. If I make it to a positive number, it's going to go to the right. If I make it a negative number, it's going to go to the left. Now, the reason it's not the opposite as I had showed you before is because all I'm doing is saying my H value is like here. -4, which means when I would type it into here, then I would make it a +4, double negative. So H is just going to adjust left and right, no matter what value I have. That's cute. Let's look at K now. K is going to be up and down, up and down. So those are the easy ones. Let's look at what A does. Now A said it was a vertical stretch, meaning a stretch up and downwards. If I make it bigger, noticing it's kind of like I'm taking the top and the bottom. I'm grabbing the top and the bottom. I'm just kind of stretching it, almost like you had like a rubber band. And if you had a rubber band and you were stretching it, it's going to become a lot thinner. And if I was doing something smaller, like, so let's see, I started at 1. I was going to go smaller, like 1/2. Notice how I'm compressing it, meaning it's kind of getting fatter now. As soon as I go negative, same rules apply, but I just keep stretching, or less than -1 will be a compression, meaning it's going to stretch, or it's going to get fatter. Let's go back to 1 here. Now B is going to do the same thing, stretch and compress, but now horizontally, meaning from the left and right. So think of the rubber band again, and you're grabbing it from the left and right end of the graph, and you're pulling it. If it's bigger, it's going to be stretched sideways. And if it's smaller, it's going to be flattened out more. So kind of help that understand. If it's bigger than 1, it's going to be stretched. Smaller is going to be compressed. And the negative rule also applies here, but you don't see it. Because like if I'm at 1 and then I go to -1, they look kind of the same. Now the reason is if I'm only grabbing from the left and right, if I was to go negative, I'm just flipping it. And a parabola is going to be the same either way. It is possible to have multiple. For example, if I was to go, let's go 2 here, 2 here, let's go 1.3. Let's change this to a -4 and this to a 4. So it's all going to be working together to create this new graph from my original graph. That is why, once again, that image I showed you, this one right here, is going to be very, very, very important for you to understand and almost memorize to help you understand how to graph them a lot easier. There's going to be plenty of opportunities in class where I'm going to say, what does the A represent? Okay, this number, is it A, B, H, or K? Now, what does that represent? Always have this handy. Even as an index card will be great. Because that's your first step to understanding graphs. You're going to have a lot more information on these coming up, a lot more videos. But this is just the intro to help you understand what we're going to be doing.